Thanks, David. It is my great pleasure to introduce to you Tim Phillip and to welcome him to our workshop today. Tim Phillip has enjoyed science since he was old enough to read. Having worked in technical fields all his life, he shares his love of science with readers weekly in the Expositor. That's probably where you know his name from. In his life, he has worked on projects as diverse as computerization of railway locomotives, electric traction control systems, and he also designed electronic warfare systems for the Canadian Navy. He has been involved in the internet since he started a free net program that brought internet service to the city of Brantford. Welcome, Tim. We look forward to your presentation.
Well, thank you for that introduction. I appreciate it. And I'm very happy to be here. And I'm also happy to try and share some of my love for science and some of the things that have become important to people. And one of the things that we're talking about in terms of importance is climate change. And climate change is something that is, a lot of people think they understand what it is, but it's something that is extremely complicated, and it's something which even many scientists have difficulty understanding. So I'm going to try and take you through a little bit about what climate change is and what climate change isn't. And then hopefully at the end, I'll have stirred some questions, and I'd be happy to answer them as best I can. So I'm going to share my screen now, which there we go, which will give you the presentation here. What we're trying to do is we're trying to understand what it means, what climate change means. And I think it's important that we realize that the Earth's climate has never really been stable. We've always had climate change. We've had periods when there were no glaciers. We've had periods when the entire Earth was covered with ice. So when we talk about climate change, there are natural conditions. There are ice ages that happen periodically. There are lots of things that happen. Actually, oddly enough, we're in the middle of kind of an ice age period right now, and the climate was starting. Temperatures were starting to drop, and they've decided that they're no longer dropping. Now I have to see how to change. There we go. So the first thing we have to look at is what is climate change? And this is where people get confused. You know, they say, oh boy, it was really hot last summer. It must be climate change. Well, it's not. Or the winter was very mild this year. That must be climate change. And again, that's not what climate change is. That's weather. And weather are just short-term changes that you see. Sometimes we have a mild winter. Sometimes we have a brutal winter. Sometimes we have a scorchingly hot summer, and other times we have a relatively cool and rainy summer. That's weather, and those are changes that happen every year, and they don't represent a long-term pattern in what's happening. Climate looks at the long-term implications of what is happening to our climate. It goes over, you know, we've been averaging over decades, and in some cases centuries, because we've actually been keeping track of the weather for a very long time. And when we look at the weather, we can start to see trends, and that shows what our climate is. So if you start looking at what's happening, we've noticed that since the Industrial Revolution started in the beginning of the 1800s, we've started burning a lot of fossil fuels, and that has increased the amount of carbon dioxide in the air. Now, I want to explain what that means. Everybody says, well, climate change is caused by carbon dioxide. Well, it is and it isn't. Climate change is caused by what are called greenhouse gases. And to understand what that means, you have to understand how a greenhouse works. A greenhouse is a structure that's got lots of glass, and the solar radiation comes in through that glass. And it's sort of a broad spectrum thing, but the glass filters out. Like, we can see all the colors through the glass because to us it's transparent. But the sun actually emits energy in a lot of different bands. It emits energy in all the visible light that you can see, but it also emits ultraviolet radiation, which is what gives you your sunburn. And it also emits infrared radiation, is what we feel as heat. Like when you go out in the sun and you feel the heat on your skin, that's infrared radiation that's doing that, but you can't see it. So when the light goes through the greenhouse gas, infrared light manages to get through, and it's inside the, or rather, sorry, ultraviolet light gets through. When it gets inside, it touches a surface or something, it releases some of its energy, and that energy comes out as infrared radiation, but it can't get back out through the glass. So the greenhouse just gets hotter and hotter and hotter. And that's the whole purpose behind a greenhouse, is to create a nice, warm and stable climate for plants that you're growing. Well, the same thing happens on the earth, where you have these gases that do exactly the same thing. They allow ultraviolet radiation to get in, but when that radiation hits the ground and is converted into infrared radiation, it can't get back out. You may have noticed in your life that when, especially in the summertime, when it's cloudy, it's warmer. And that's because the even water vapor is a bit of a greenhouse gas, and it tends to keep the heat in the earth. When it's not cloudy, it tends to be very cold. So that's a little bit of an explanation about what climate change really is and what's causing it. Now, I talked about there being a change, the Earth's climate being changeable, and the Earth's climate has always changed. Now, if you look at this graph over here on the left-hand side, you'll see temperatures. Now, these are, I apologize, they're not in Celsius, but these temperatures are listed in Fahrenheit, and you can see that, and these are average temperatures, which means some places they're going to be higher, some places they're going to be lower. So if you go back 500 million years, we were way up here, about 100 degrees Fahrenheit. And that's moved, up and down. And sometimes, and this line right here, it shows you a world above it. There are no ice caps at all. There's no ice on the planet other than temporary ice, maybe in the wintertime. But there are no permanent ice anywhere on the planet. If your temperature is below this line, which is about 68 degrees, you can have permanent ice caps at the poles. So as you can see, we've gone through many, many areas. In fact, if you go back to the beginning of the Earth, when the Earth finally cooled down to the place where you could have liquid water, there were times when there was no ice anywhere on the planet, and there were other times when the entire planet was covered by ice. They called it snowball Earth, and that was a period when virtually all the water froze, except maybe a tiny band around the equator. So this shows what's been happening over many years, and the cause for this. Well, there are changes in the sun's output. There are changes in the Earth's orbit. There are massive infusions of greenhouse gases, particularly carbon dioxide and sulfur dioxide, that come from volcanoes. And there have been periods in the Earth's history when volcanoes, particularly up in the Russian steppes, basically erupted for more than 1 million years. Now think about a volcano that's continuously erupting for 1 million years. And that put a lot of greenhouse gases in the atmosphere. And that's where you get these spikes and things that are happening. So climate change is a normal part of our Earth. There's nothing special about climate change. The climate's already changing. In fact, if you go back about 50,000 years ago, the house that you're sitting in was covered in about 1 mile of ice. If you go north to Cambridge, all those big hills that are just south of Cambridge, they're the remains of, like if you go up into the Canadian Shield, you'll find that the Canadian Shield doesn't have a lot of topsoil there. Well, glaciers came down and scraped all the topsoil off the Canadian Shield and brought it down. And when the glaciers receded again, they dumped all that soil. And that's where you get all those moraines and things up just south of Cambridge. So there's a lot of changes in our climate that have happened, and climate change is a natural thing. But you'll also notice that these changes took place over very long periods of time. Even these little spikes over here, that was probably 5 million years it took to do that. So the change happens fairly slowly. So what causes it? And by the way, when we talk about climate change, the thing that we're worried about is not the normal climate change that happens on the Earth as just part of the way the Earth works. What we're talking about, it's called anthropogenic climate change, which basically means it's our fault. We're doing it. And that's when you look at factories like this. We're burning fossil fuels, and we've been doing that for a long, long, long time. I mean, pretty much as long as there's been civilization, we've been burning fossil fuels, but we started doing it on an industrial scale starting in the early to mid 1800s, in the 19th century. And a lot of like when you dig up coal or oil, they used to be plants, and the earth captured a lot of carbon in those and then buried it. Now we've dug it up, and now we're burning it and returning all that carbon dioxide to the atmosphere. Transportation, electricity, and industry are the biggest sources, like power plants, like Natticoke. That was one of the largest sources of carbon dioxide in North America, the Natticoke plant. They burned coal. And they had a lot of sophisticated technology, but they still let out a lot of carbon dioxide. Other things that do not help, trees have an interesting cycle. We breathe in oxygen and we breathe out carbon dioxide. Trees do exactly the opposite, and all plants do exactly the opposite. They will take in carbon dioxide and they will emit oxygen. In fact, when you look at trees and you look at other plants, most people think that all that material that you see came from the earth and the plant bringing up nutrients from the earth. In fact, most of the structure of most plants actually came from the air by pulling the carbon dioxide out of the air. So those are things to think about. And as we're cutting down forests and removing trees, we are removing one of the sources for taking carbon dioxide out of the atmosphere. I was just reading a report this morning, actually, and I didn't have the next couple slides in my presentation because I just found it this morning. But 80% of the global CO2 emissions, that's carbon dioxide, come from just 57 companies. Think about that. 57 countries are responsible for 80% of the CO2 emissions. And you have to be careful saying, well, that just shut them down. Well, you shut down power plants, and that creates a big problem for everybody. And here's the interesting production of oil, natural gas, and cement. By the way, making cement generates a lot of carbon dioxide. The chemical processes by which we make cement puts out a lot of carbon dioxide. So if you look at this graph, the black you have coal, the brown you have oil, the bluish color is natural gas, and then the gray part is cement. And the line just shows the sort of the global total. And interestingly enough, we had an agreement called the Paris Agreement, where everybody agreed to try and cut carbon dioxide emissions. And you'll notice that after that agreement, there is a small drop in the emissions. And then it goes up, and then there's another little drop. Well, that you can thank COVID for. But beyond that, you'll notice that at the very end of the graph, we have a situation where the production of greenhouse gases are continuing. And as I said, carbon dioxide is not the only bad one. Methane. We factory farm cattle on a huge industrial scale. The idea that a farmer is some guy who's sharecropping 150 acres and he's keeping some beef cattle and some dairy cattle. That's not the way it works. We have huge factory farms now that have 10,000 head of cattle in one farm, and they're feeding them on an industrial scale. And cows have a very inefficient digestive system, and as a result, they end up emitting a lot of methane out the back end. And methane is basically natural gas, and natural gas is 200 times more effective as a greenhouse gas than is carbon dioxide. Now, I talked about the sun, varying its output a little bit, and the Earth's orbit being varied. And this is a bit of a complicated graph, but I wanted to show you something. If you look over here, This number here shows how much energy the sun produces. And it's 1,361 watts per square meter. Now, what that a square meter is about 9% bigger than a square yard. And the sun, when it's directly overhead, puts about 1,361 watts of energy onto that space. That's enough to run, the heater that you plug into your wall? That's enough to run that 1 square meter of energy from the sun. And if you look between here and the peak and the valley here, you're talking less than a watt's change. Like this, our sun is extremely stable. These little fluctuations you see are things like sunspot cycles and things, but the yellow line just shows that the sun's output is very stable. Yet if you look at the line here in red, and this is the scale over here, we've gone from an average temperature on the planet of roughly 0 degrees Celsius or 32 degrees Fahrenheit, and we've gone up a full degree Celsius. Now, that doesn't sound like very much, but when you're talking about the average of the planet, that's very serious, because we may not notice a lot of that, but areas up in the Arctic where all the ice is that's staying out of the water, the effects are much greater up there. So small changes in average temperature can have big changes, particularly in the Arctic. So what are the impacts of this? Well, we can look forward to, and by the way, a lot of the things I'm talking about, we probably are not going to be seeing. I mean, we'll start to see some of it, but it's going to be our children and our grandchildren and great-grandchildren that are going to have to deal with this. And I've got we're actually not very good at dealing with these types of things. But let's look at some of the effects. We're going to start seeing extreme heat. Now, that's going to be more dangerous down in the tropical areas, but they're kind of used to having really warm days. We're not used to having that kind of heat. I mean, we'll have 30-degree temperatures here, but what are we going to do if the temperature in Toronto becomes 40 degrees Celsius? That's going to be very difficult. We don't have the generation capacity to give everybody an air conditioner to help them. So heat is going to, and heat, of course, is especially bad for seniors. If you're trapped in a place without air conditioning, you're in serious trouble. The other thing that's going to happen is that everybody has the idea, well, global warming, that's going to help Canada, because that's going to move the band of the American Corn Belt and all that. It's going to move it north. And to some extent, that's going to be true. But it's going to bring a lot of other things with it. Changes in weather patterns, which mean areas now that have abundant rain may end up having almost no rain. Wildfires due to the heat. The storms that we get are going to be far more intense. Like, you think of a thunderstorm, a bad thunderstorm. Well, if you add more energy into that system, and all the weather that we have is driven by the sun, and if that heat that the sun gives us can't escape, that's energy that's going to be available to go into storms. And those are going to be far more worse. Floods, storms usually bring floods. We have ice caps. Now, I'm not concerned about the one at the North Pole because it's floating. And if you took a glass with ice in it and then you filled it up with water right to the brim and left it until the ice melted, you'll notice that the level of the water won't change. So if the polar ice cap melts, who cares? However, Greenland has one of the largest reservoirs of ice. If you go to the center of Greenland and stand on there, you're standing on 3 miles of ice before you get to the bedrock. Antarctica has massive ice things that are on land. It's not part of the water. So if you start melting that and the water runs into the ocean, or those ice things slide into the ocean, we're in for dramatic, and I mean dramatic, sea level rise. And I'm going to show you that in a moment. And the other problem, of course, is when climate changes, where we grow crops where it's suitable to grow crops. And So you have a certain amount of rain you can count on each year. You're going to grow crops that can live in that amount of rain. But when the climate changes, the rain patterns are going to shift. So something that you grew perfectly well before, I mean, corn likes warm, wet springs, but really hot, dry summers. Well, what are you going to do if it rains all summer? You know, your crops are not going to grow as well. Here's another thing to look at. The picture up at the top is looking underwater at a kelp forest. Kelp is an algae plant that grows in colder water, and this is in the Pacific Ocean. And it basically provides habitat for fish and keeps the place healthy. And if you look down at the bottom, it shows, this is a satellite photograph that shows the kelp canopy as it existed in 2008. If you look at the next one beside it, the kelp canopy in 2019 is gone. The water is getting warmer. In fact, when the kelp goes, what basically is left is dry, sandy, or not dry, but sandy sea bottom with no life. Except for one thing, as the kelp dies, it'll fall down to the bottom, and spiny sea urchins, which eat kelp, will have a field day until all the kelp's gone, in which case they will die as well. I talked about sea level rise. I hope nobody here has land in Florida, because if you look, Florida will disappear if the Antarctic and Greenland ice sheets go into the ocean or melt. All of these cities that you see, Boston, New York, Washington, well, no great loss with Washington, Charleston, New Orleans, Houston, Miami, even Havana. You notice Cuba used to be a one island, won't be in the future. So North and South America will be disconnected from each other, and not just by the Panama Canal. They'll be able to just sail through it. San Diego, that'll be in the water. San Francisco, the high parts in the hill will still be above water, but that's about it. This is a dramatic change to the map that we're looking for. And you'll notice that Florida is missing completely. I think the highest elevation in Florida is about 100 feet above sea level, and you're going to get that kind of rise. I will tell you that I don't remember how many million years ago, but probably the last 65 million years, there used to be a sea that ran up through this area here. It was I think they called it the Tethys Sea. And that's because there were, at a time when there was no ice on the planet. And we may not have that same experience this time, because this whole continent that you see here is slowly moving to the west. It's called continental drift. This section here in the Caribbean, that used to fit right into Africa. And South America used to fit into it as well. It's a very nice fit. There's a guy named Wegener who theorized this theory of continental drift, and we now know how it works. And because the continent's been moving this way, and the ocean section has been going this way, they've collided. And that's what's brought up all these mountains that you see, the Rocky Mountains, the Sierra Nevadas, all of those are because these two plates have collided. And what it's done is it's lifted North America up a little bit. And I mean, if you go and find fossils in the Brantford area, you know, you go out into a field and you're digging up stones and stuff, you may find some fossils. You'll find fossils from underwater creatures, because Brantford was at one time underwater. And because we're being lifted back up after all the glaciers pushed the continent down, and it's slowly coming back up, we may be okay. But as I said, if you own any Florida real estate, don't count on passing it on to your great-grandchildren, because it won't be there. England, one of my favorite places. I hope you don't like London, because London's going to be underwater. Bournemouth underwater, Bristol underwater, Peterborough underwater, Norwich underwater. Birmingham will still be above the water. Manchester will be in the water. Newcastle will be in the water. Edinburgh will be in the water. That's what we're looking at. And if you look at a map of where people live, more people live near the ocean than anywhere else. And the ocean is going to swallow them. You know, you look back on all of the stuff that happened in New Orleans when they had the hurricane come in and the levee burst and a whole bunch of areas are flooded, and the government spent billions of dollars rebuilding this. And all I could think of is, why? It's going to be flooded again and again and again. So why do that? But maybe that's why I'm not a politician anymore. So we talked about other things. Storms, electrical storms and thunderstorms are driven by heat. And the more heat that you have, the more energy there is to go into these storms. Tornadoes are going to be worse and they're going to be more common. I can tell you that there's a whole band where tornadoes are common. They call it Tornado Alley, and it runs through Kansas and areas like that. That area is actually moving to the east. And we may find ourselves in another, 100 years right in the middle of Tornado Alley. We've had a few tornadoes here. We're not prepared for it. We don't build to a tornado standard in the building code. So there's going to be a lot of issues when that happens. As well, floods, storm surge. Water is very powerful. You see the picture on the left there that's concrete. Given enough time, those waves will beat that concrete into small rocks. And the other side is a satellite picture of a hurricane. And there will be more, these things are they're created over water and they're driven by heat. And the more heat that is available, the bigger the hurricanes. I don't think there's anybody old enough here to remember, but my father used to tell me about driving from Hamilton to Brantford when Hurricane Hazel came in. And it was devastating. It flooded rivers. It caused all kinds of transportation problems. It was a mess because we're not used to getting hurricanes. Better get used to it because we're going to see more of them. And this is the impact of climate change. And I wanted to show these, the little comic here, 56 million, the continents move around the Earth. And, at one time, Antarctica was right on the equator. And Greenland, 56 million years ago, had an average temperature of 85 degrees. It had tropical animals there, tropical plants. And now it's got 3 miles of ice. Now, the photograph on the right, there are two photographs there. The one at the top was taken 100 years ago. The one at the bottom was taken 100 years after the first one was taken. Now, I want you to notice a couple things. You see this peak up here with the little ledge, etc. And then there's another little one poking up here. And then you can see this kind of flat area with this peak that comes down. Well, here's the first mountain, and there's the little nubby peak that we saw. Here's the little tiny thing that was sitting in the middle. And here's the flat area on that. And look where the ice is. That's 100 years. And that was before global warming started working the way it is today. So, what can we do? Well, I'm going to give you a list of things that could be done to help mitigate climate change. I will tell you that I'm not optimistic. The curve for showing the increase in temperature is it's starting to climb almost straight up. We have had more average change in temperature in terms of climate, not in terms of weather. We've had more change in the last 25 years than we have ever had. And all of the models show that we are the ones doing that. And the problem is they create climate models to try and understand this. And they go back 100 years when we have good weather things. And they run these climate models and see how they match with what's happening. And the problem is that there are too many assumptions in these models. These models they're the best that we can do, and they do very well. But the way climate works, very small changes can end up with extremely different results on the other end. It's called the butterfly effect, that you make a small change over here, and then 10 years later, the weather that you get in the world is going to be completely different. The idea is a butterfly flaps its wings in Seattle and there's going to be a typhoon in Japan. Well, that's a bit specious, it does illustrate the idea. Small changes in climate make for big changes in the future. So, health risks. I already talked a little bit about this. Seniors are especially vulnerable to heat-related illnesses because as you get older, your ability to regulate your temperature is not as good as it was when you were younger. And while you may think that you're really only 25 years old and wondering what the hell happened to your body, I can tell you that your body knows how old it is, and it's starting to, age. Routines. You have an emergency with climate, a hurricane, a flood, whatever. There are a lot of seniors that are out there that are going to need mobility aids. You're going to need to be able, how do you evacuate these people? All of this needs to be taken into account. And the other problem is thinking about climate change and experiencing some of the effects of climate change can really affect people's mental health. And you have to keep a perspective. Climate change will change things dramatically, but for everybody that's on this Zoom call here, probably will never see the big effects. So it's nothing for us to worry about, but it is something for our children and grandchildren to worry about. Solutions, individual actions. Change always starts with the individual. You try to use public transportation rather than driving. Walk if you can. Reduce waste because, the landfills generate a lot of not carbon dioxide but methane. If you recall, about 30 years ago, I think they had a scale building at the dump here in Brantford, and I guess they had a motor or something underneath it to pump something, and they turned it on, it generated a spark, and it blew the thing up. I think there was a man very badly injured in that thing. So the less waste we can put in the landfill, the better we are. Community support organizations like this, learning about climate change and advocating for solutions, with the politicians, the people that make the decisions are always good. So, in summary, despite what some naysayers will tell you, climate change is real. There was some dispute about whether it was caused by humans, but the science on that has been pretty well settled. If you want to prevent this, I think they're talking about if we have a 2.5-degree rise in temperature, it becomes, because of the instabilities and the way the mathematics and all this works, if we get a 2-degree rise in temperature, there's going to be nothing we can do to stop it. And who knows how high it's going to go. So we need to take some action now. And if you looked at remember that graph that I showed, the carbon dioxide by coal and oil and methane, and how it, after the Paris Climate Accord, it dipped a little bit, then it went back up again. With COVID, it dipped a little bit and then went back up again. I have to tell you, I'm not terribly optimistic that we're going to fix this problem. You have a lot of political issues. Third world countries look at the first world countries like Canada, the United States, and Europe, and they say, well, you guys went through your industrialization period and you didn't give a damn about the climate or the environment or anything else. And now that you're rich and you've got everything, you're telling us that we can't industrialize and we can't share in the wealth that you've already achieved. And when you have China getting most of its electricity from coal, and coal is one of the dirtiest fuels that you can use, I'm not optimistic that things are going to change. People do things that make them comfortable. And listen to all the bitching about the climate or the what do they call it, the climate tax that the government's put on. Everybody's whining about that. It'll destroy the economy. It'll do this. Well, if you think the economy is going to be destroyed by a carbon tax, wait till you see what global warming is going to do to the economy. It's going to destroy it pretty badly. And, the only way you're going to get people to change is you're going to have to make it uncomfortable to do the things that are causing the climate change. So if you took the price of gas and made it $5 a liter, that would reduce the amount of trips that people took. And you'd think twice before jumping in the car and going for a drive, because it's going to cost a lot of money. The problem is the political systems that we are in will not allow a politician to make those changes. Trudeau putting out the carbon tax, that's probably going to be the thing that causes him to lose the next election. Our political systems are not set up to fix this problem. And I don't have a lot of optimism that it's going to happen. And that, I've always been a cynical old bastard, but I look at this, I don't see us changing. We don't react to things unless it's really biting us and biting us hard. And climate change will bite us hard, but by the time we see those effects and it does bite us hard, it'll be too late. Boy, what a great way to end a presentation, with a call to action and say, oh, by the way, it really doesn't matter. It's going to happen anyway. So that's the end of my presentation. I hope you found it informative, and I hope you found it useful, at least in understanding what's going on. For people our age, I wouldn't worry too much about climate change, but certainly our children and grandchildren and great-grandchildren are going to be dealing with the effects of this. And at least now you know something about it, and when people talk about it, you'll have an idea of what they're talking about. So I'd be happy to take any questions.